Hey guys, welcome back to Introduction to Node.js, Express.js and MongoDB. My name is Kaustubh Garge, but you can call me KG. In this session, I will be covering session 4, which will be covering MongoDB. Before we begin, let's look at the session outline. In this session, we're going to be covering what NoSQL databases are. We'll be doing a refresher on promises, which is very important when we work with Express applications as well as MongoDB. We will be learning what MongoDB is, why use it, and we will cover the installation and the fundamental concepts of MongoDB database. So before we begin, let's also do a quick recap of what we learned in the previous session. So in the first session, we covered the fundamentals of JavaScript programming. We covered the most important concepts of functional programming, which we will be using often while working with Node.js. In the second session, we understood what Node.js was. We installed Node.js on our systems. We understood what Node Package Manager was, how the package dependency and how the modular code works within the Node.js ecosystem. And we built a simple Node.js application using the packages that we got from npm. In the third session, we used a framework called Express.js to build HTTP RESTful applications, where we learned routing and all the other concepts related to Express.js. Not just Express.js, but these are the concepts that are very specific to building a web server. In this session, we are going to be covering how to connect that web application server that we have built using Express.js to the MongoDB database. Alright, so let's begin. So before we actually understand what MongoDB is, we need to understand what NoSQL databases are. NoSQL or NoSQL is, however you want to call it, is referring to the non-SQL or non-relational databases. So before we understand NoSQL, it is helpful to understand what SQL is, which is a query language used by relational database management systems. Relational databases usually, or not usually, but they always rely on tables, columns, rows, or schemas to organize and retrieve data. In contrast, NoSQL databases do not rely on these structures and use more flexible data models. NoSQL usually can mean not SQL or not only SQL. They're particularly useful in storing unstructured data, which is growing far more rapidly than the structured data in today's rapidly changing digital world, which may not always be good fit for the relational schemas of relational database management systems. One of the common types for unstructured data is user and session data or chat messaging. So if you use any sort of chat messaging, the relational database systems are not that efficient and they don't scale well enough as much as NoSQL database systems can. We can also think the data that we get from IoT devices, the device data, the large object data such as video and images, which are perfect use cases for using NoSQL databases. So there are actually 4 different categories of NoSQL databases. The first one is key value data stores, which uses the key value pair for storing data. The second one is document stores, which we will be working on since MongoDB follows this approach. Document databases typically store self-describing JSON, XML, and BSON data. The third one is wide column stores. Wide column stores are NoSQL databases which store data in tables with rows and columns similar to relational database systems, but the names and formats of these columns can vary from row to row across the table. And finally, the last category of NoSQL databases is graph stores, which are relatively new. Not that new, but they have been implemented. They're beginning to be implemented in various systems, various production systems. The graph database uses graph structures to store, map, and query relationships. Alright, so let's move ahead. Okay, so before we jump into MongoDB, let's do a quick refresher on promises. We have actually covered this in the previous session, but still we will do a quick refresher on promises. So promises. Promises are very important in JavaScript. Make sure you understand this very thoroughly because you will be using this in advanced JavaScript and especially in various JavaScript frameworks such as Node.js as well as the front-end frameworks such as Angular. Promise is commonly defined as a proxy for a value that will eventually become available. So imagine you're a kid and your dad promises you that he will take you camping next week. So now you don't know if he'll go to the camping. Your dad can take you camping, or he might not take you camping because he might be busy, right? So that's a promise. A promise has three states. So let me go back in here real quick and open up the console. So a promise has three states. The first is pending. The next one is fulfilled. And the last one is rejected. Okay, so pending is that you don't know if you'll go to camping. Fulfilled means your dad takes you to camping because he's not busy. Okay, the not busy is a condition that we have to check. The rejected, that means your dad does not take you to camping because he's busy, right? So let's write some code for this. Let's codify this. So I'll just clear this console out, and I'll declare a variable to see if dad is busy. So I'll say is dad busy. So currently he's not busy. And let me create a new promise. So this is how you create a new promise. I'll declare a variable, take me camping, and this will either be fulfilled or not fulfilled. Will take me camping, this promise. So I'll say new promise, and inside this we pass in a function. So I'll say function resolve reject. Okay, so just ignore this, I just accidentally pressed enter right here. In this we have to see if dad is busy. So I'll say if dad is busy. So I'll say if dad is not busy, and in here I'm going to, if dad is not busy, then we are going camping, right? So I'll create a object for camping which will have all the information about camping. So I'll say where we are going. So let's say we are going into the state of Wisconsin. The time, say we are going at 10 a.m. The day, say we're going on Sunday, and that is it. Okay, now since dad is not busy, we are definitely going to camping. So I'm just going to resolve this request. That means the request has been fulfilled. So resolve camping. So that means the request has been fulfilled. And if dad is busy, then we have to give a reason because dad is busy. So I'll just say var reason equals new error. I'm just going to throw an error, and the reason is dad is busy. And I'm going to reject this with the reason. So which means we are not going to camping. Okay, so this is how we create a promise. And if I now see if will dad take me camping, the promise is resolved because dad is not busy, and that's why we're going, right? But what if dad is busy? So if I say and I create this again. Then I get an error. I get an error saying that dad is busy, so we are not going camping today. Great. Let's go back. So what is MongoDB? MongoDB is an open source NoSQL database management program. It is a tool that can manage document-oriented information, which is used to store or retrieve information. When we say document-oriented system, where documents are the basic unit of data in MongoDB. The documents are similar to JSON, but we use a variant called binary JSON, which literally stands for BSON. The benefit of using BSON is that it accommodates more data types. Like other NoSQL databases, MongoDB does not require predefined schemas, so it can store any sort of unstructured data, which gives us the flexibility to create any number of fields in the document, making it easier to scale these databases compared to the relational database management systems. So here is a slide explaining what MongoDB is, which I already discussed. Moving on to the next slide, why use MongoDB? There are 4 reasons that I can give you why we should use MongoDBs. The first one is that it supports dynamic schemas. The MongoDB's dynamic schema provides a simple way of implementing changes as the application requirements change. These changes can be made to the database without affecting the existing data or application code without incurring any downtime. So consider a rapid application development program that your company has undertaken. So for example, before building a specific product, so let's say if you wanted to build a social media application, networking application, you wanted to build a small prototype to test on, let's say, 10 or 20 users, and if you wanted to scale it up gradually from 20 to 200, from 200 to 2000, to do that, the requirements and the functionalities of the underlying application will change rapidly. Okay, so to incorporate these rapid changes, MongoDB is a perfect system because MongoDB's dynamic schema provides a simple way of implementing these changes. This would not be possible or easy in terms of relational databases. This is why MongoDB is much more better. The second reason why we should use MongoDB is the ease of deployment. Since MongoDB was built to work with cloud architectures, the data is localized for queries to ensure performance, okay, regardless of the deployment size. So let's say if your application rests on the cloud architecture, let's say it rests on AWS or Azure or any of these cloud platforms that are scattered across various regions, the way MongoDB is set up, that it can be deployed anywhere within the region, and we can quickly query the data no matter where it rests, no matter in which region it rests. The third reason why we should choose MongoDB is, of course, the ease of scaling. Since we talked about ease of deployment, the next possible evolution with that is a ease of scaling. So MongoDB is designed to be designed to allow scaling across server clusters. So as data volumes increase, organizations can simply add more nodes to their clusters, and MongoDB will automatically balance the data in the background. Okay, balance the data seamlessly in the background. The last, or one of the final reasons I think is most important on why we should use MongoDB is the rich querying experience. So MongoDB provides a full query language and primary and secondary indexing as well, and the full text search is somewhat similar to like Google like syntax search. Okay, it is also good for following applications that I think are more important. So one of the most clear examples is product catalogs for e-commerce, sites such as blogs or content management platforms, or anywhere you have to provide real-time analytics and high-speed logging, or if you want to provide geospatial data, or if you want to use ever-evolving applications such as social networking sites. Okay, this is where MongoDB really stands out. The data in the MongoDB has flexible schema, so they do not enforce the document structure by default. This flexibility allows you to data model according to your choices and match to the application that you're building and provide the performance requirements that you need. All right. So moving on to the data model, like I mentioned right now, is that MongoDB's data model makes it easier to store and combine data of any structure. That means it has a flexible schema, and MongoDB has a concept called collections, which we'll see in just a moment, which do not enforce the document structure by default. This allows the flexibility and gives you it actually gives you flexibility to select your choices for data modeling based on the application that you're building. Okay, you can dynamically modify the schema without downtime, so this is very perfectly suitable for rapidly evolving applications. Moving on. So the installation. So let's move on to the installation phase. So before we jump into the installation, make sure you jump on to the mongodb.com and check out their website. You can take a look around. I strongly encourage you to take a look around and look at the different products they have, as well as check out the documentation. We are not going to install MongoDB on our local systems. Instead, we are going to be using something called MongoDB Atlas, which is a fully managed cloud MongoDB service. The reason why I'm choosing to use MongoDB Atlas is because we don't have to make technical or any sort of complicated changes to your local system, and we will just understand how to set up MongoDB on the cloud, since it is most suitable for using it on a cloud architecture. And we will connect directly to the cloud and work over there. So let's begin by creating a free account. I already have a free account, but I'm going to be helping you walk you through it. So in here, when you get to the sign up page, you can enter a company. It's optional, but you can enter any fictional company, it's fine. The next step is you can say that I'm learning MongoDB. Enter your work email address. So I'm just going to say my email address, and I will sign up, and I'll be right back. So after I entered all my information, it takes me to the configuration page. Over here, we are going to be using the free tier on which we'll create a cluster. Make sure you choose the shared clusters option. Since it is free, you don't have to put in any sort of credit card information. So I'm going to select the free tier. I'm going to select AWS as cloud provider, and I'm going to select a region that I'm closest to. Okay, the next thing I'm going to select is I'm going to select the cluster tier. All of the default settings are fine. The cluster name, I can select whatever I want, but I'm okay with the default cluster name. I need to make sure that the amount over here is free. It says your monthly estimate is $0 a month. Your M0 cluster is idle for experimenting in a limited sandbox. That's what you want to set up. Make sure you set it up with this cluster and you don't pay for any of the production level clusters. So I'm going to go ahead and select create cluster, and it is going to take me some time to create cluster. Okay, so let this get created and I will talk with you soon. Alright, so the cluster got created. So if we look around, the cluster is created, and now we have to load a sample data set. Okay, so I'm going to select load sample data set, and after we load the sample data set, once it is done, I will select connect over here, and the first thing we need to do is set up the connection security. Okay, since we are doing this in a sandbox environment, we are not really concerned about the security. Of course, we'll be storing some test data, not anything that is sensitive and that is not suitable for a production level system. So I'm going to just say allow access from anywhere, and I'm going to add IP address as 0.0.0.0/0, and I'm going to say that this is public. Alright, now in here I'm going to create a database user that will have access to this project. Okay, so I'm just going to create a test user with a password I'm going to save it, and next thing I'm going to move to the connection method. Alright, so there are different ways we can connect to this application. First is obviously we can connect it using the Mongo shell. The Mongo shell is installed when you install MongoDB on your system. We haven't installed this, so we are not going to be covering the Mongo shell within this course. The next step is you can connect to this cluster by using your application. So for example, if I select this, we can connect using Node.js. We'll get back to connecting to Node.js, but in just a moment, as the data is being loaded on the back side. So let's look at other option while the data gets loaded. The next option is to connect using MongoDB Compass. So we'll be using MongoDB Compass to visualize the data that we add. So head over to a new tab and search MongoDB Compass, and open the first link that says mongodb.com with products and Compass. Select on it, and you can see and understand why we use MongoDB Compass. It's much more easier to have a look at your data and run very short queries to extract any piece of information you want from the database. So I'm going to be just selecting the download button at the very end, and I'm going to be selecting the version that is specific to my platform. Now I already have MongoDB Compass installed on my computer, so I'm not going to be installing it, but make sure you install the version appropriate for your platform. Let me go back and see if the cluster has been created and the dataset has been loaded. So I get here that the sample dataset has been loaded. Access it in Data Explorer by clicking Collections button or with a Mongo shell. So let's click the Collections button and see the sample dataset that has been loaded. So if you notice here, within this dataset we have 8 databases and 21 collections. So on the left hand side over here you have the databases. So the database over here is saying sample underscore Airbnb, and within it we have a collection called listings and reviews. Okay, so if I look at listings and reviews, I get the title, I get the collection size, I get the total number of documents that are available within this collection. And if I scroll down, I get to see the sample documents within the collection. So if you notice here, it is giving me the data that is very specific to Airbnb listing. Okay, so if you notice, we have an ID, we have listing URL, we have name, summary, space, description, neighborhood overview, etc., 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 and you have about 5,000 of these documents within this collection. Okay, if you look at the other databases, we have this sample analytics database which has multiple collections. So if I select the account collection, we have the collection size of about 218 kilobytes with the total documents of 1746. And if I scroll down, I can see that the accounts have ID, the account ID, the limit, and the products. Okay, so this is sample analytics. Now what we are going to do is we are going to create a database of our own and connect it using a Node.js application. So let's create the database and connect it using Node.js application, and then we can understand the fundamentals of MongoDB. All right, we'll see you in the next video. Take care.